Hello everyone, welcome back to mahafarka.co.in. In today's video, we are going to learn about one of the most important article from this lesson, oscillation, that is differential equation of Shm. Now, in a previous video, you have learned about the linear Shm. What is linear Shm? In which restoring force is always acts towards the mean position and the magnitude of restoring force is directly proportional to what? Displacement of the particle but in a opposite direction. This type of motion we are going to call it as what? Linear simple harmonic motion. Now, suppose consider a particle of mass m is performing linear Shm. Let x be the displacement of particle. X be the displacement of particle and omega be the angular frequency of the particle. Okay. Now, if you remember in the mathematics, you have learned that if v is the velocity, then velocity is what? Rate of change of displacement. Velocity is what? Rate of change of displacement. Therefore, we write velocity is always equals to, in terms of derivative, dx upon dt. Also, we have learned that acceleration is what? Rate of change of velocity. Acceleration is what? Rate of change of velocity. So, acceleration here can be equal to what? dv upon dt. This dx upon dt, if I put for v, then it is like d by dt of dx upon dt. Then it can be like d square x upon dt square. A equal to what? D square x upon dt square. Write velocity as dx upon dt and acceleration as what? D square upon dt square. So now let's start the deriving differential equation. Before the differential equation, it is the equation in terms of derivatives. We write that equation in terms of rate of change of one factor to the another factor. Okay. So particle is performing linear simple harmonic motion. X is the displacement of the particle and omega is the angular frequency. So in linear Shm, in what? Linear Shm, the restoring force is given by F is equals to minus k into x. So this is equation number 1. Now, by Newton's second law of motion, what is the basic formula for force? Force is equals to what? Mass into acceleration. So this is equation number 2. But already I told you, if x is the displacement of particle, then acceleration can be written as what? D square x upon dt square. So substituting here. So what I will get? F equal to what? M into d square x upon dt square. So this is equation number 3. Now see, equation 1 is also representing the force F. Equation 3 is also representing force what? F. So I will say from equation 1 and 3, what I can say is m into d square x upon dt square is equals to what? Minus k into x. This m will come in division this side, so I can write, or dividing both sides by m, it will like d square x upon dt square equal to minus k upon m into x. Okay, what is this minus k upon m? But we know that k equal to what? M omega square. So if I substitute d square x upon dt square is equals to minus m omega square upon m into x, then finally I am going to get d square x upon dt square equal to minus omega square. Shifting this minus term to the left side, what we'll get? D square x upon dt square plus omega square x equal to 0. This equation, this is the differential equation of Shm. This equation is very useful for studying the linear simple harmonic motion, and it's quite simple also. We just need to keep these two formulae in the mind. First formula is of restoring force, and second formula is of what? Newton's law. That is second law. Force is equals to mass into acceleration. Rest all things are very simple. I hope you understood today's article. Thanks for watching mahasarkar.co.in. Thank you.